Again, another question of directional derivative of the given function at the point 1, -2, -1 in the direction of the vector this one. So you know that what is directional derivative? That is grad f dot a vector, and a vector is unit vector in the direction 2i minus j minus k, and grad f is equal to 2xyz plus 4z square I plus x square z j cap plus x square y plus 8xz k cap, and at the point 1, -2, -1 grad f is 4 plus 4 I cap plus 1 minus j plus 8xz, that is minus 8k. So this is 8i minus j minus 16k. Now we have to find a vector in the direction 2i minus j minus k. So a vector is equal to 2i minus j minus k by square root of 2 square plus 1 square plus 1 square, that is 2i minus j minus k by 4 plus 1 plus 1, so 6. So we have to now calculate grad f dot a vector, that is 8i minus j minus 16 minus not 16, this is to minus 2 minus 8 means 10, so minus 10k and dot 2i minus j minus k by square root of 6. So this is 16 by square root of 6 minus minus plus 1 by square root of 6 minus minus plus 10 by square root of 6, that is square root of 6 and 26, 27. Next question, if r equal to the absolute value of the r vector where r is xi plus yj plus zk, then we have to prove that this one and the second one. So let's start the solution. Since r equal to xi plus yj plus zk, then absolute value of r is equals to square root of x square plus y square plus z square, or we can write this as x square plus y square plus z square power 1 by 2. Now we have to calculate grad of 1 by r. So first question, grad of 1 by r, that is I del x plus j del y plus k del z of 1 by r. We can write this as r inverse. Now if you use chain rule, this can be written as I minus 1 r power minus 2, because derivative of this with respect to r is minus 1 r power minus 2 del r del x. We are using chain rule. Similarly, for second one, j minus 1 r power minus 2 del r del y plus k minus 1 r power minus 2 del r del z. That is, we can take minus r power minus 2 outside and then del r del x I cap plus del r del y j cap plus del r del z z k cap. Now we have to calculate del r del x, del r del y, del r del z. You can see that the function r, this is a r equal to this one. So r is a symmetric function, so we will just calculate del r del x, and similarly we will write the others. So r equal to x square plus y square plus z square power half. So del r del x is equals to half x square plus y square plus z square power half minus 1, that is minus half. With respect to x, this is 2x and others will be 0. That is, we can write 2 and 2 cancel out. So x by x square plus y square plus z square power half, that is x by, this is equal to actually r. So del r del x is x by r, and since r is symmetric function, so del r del y will be y by r, and del r del z will be z by r. Now just put the values in this equation. So the final answer, grad of 1 by r equal to minus r power minus 2. Del r del x is x by r I cap plus y by r j cap plus z by r k cap. That is minus r power minus 3 with xi plus yj plus zk minus r power minus 3 r vector. That is, we have to prove minus r vector by r cube, or you can write r power minus 3. So that is r vector by r cube minus. Now the next one is grad of r power n equal to n r power n minus 2 r. We will do in similar way. So r is this and small r is the absolute value, that is this one. So we will calculate grad of r power n. Let's start. Grad of r power n, that is I del del x plus j del del y plus k del del z with r power n. That is, if you do partial derivative or using chain rule, we can write n r power n minus 1 del r del x I, similarly like the previous one, n r power n minus 1 del r del y j cap plus n r power n minus 1 del r del z k cap. You can take n r power n minus 1 common, and the value of del r del x by r, that is x by r I plus y by r j plus z by r k. So we can write n r power n minus 1 with 1 by r xi plus yj plus zk, that is n r power n minus 2. This is actually r vector. So we are done.